When used correctly, push notifications can be an extremely powerful way to drive user engagement, but when used incorrectly, they can do the exact opposite and drive users to uninstall your app. Luckily, there's a service called Firebase Cloud Messaging that allows you to be smart about the way you broadcast notifications to your users.
Take it from me, be smart, be safe.
In today's video, you'll learn how to receive messages from a front-end Flutter app and also how to broadcast them from a back-end cloud function. We'll look at how to broadcast notifications to a single device or user, to a topic, or to a segment of your user base based on the analytics data that you collect. By the end of this video, you'll be able to combine these techniques together to create a sophisticated pipeline for app notifications. If you're new here, like and subscribe, and you can find the full source code on Fireship.io. And congrats to Mateja Petrovic, your last week's t-shirt winner, but there will be another giveaway with this video. All you have to do is leave a comment below. Now, before we get into the actual source code, let's talk about the three main ways that you can send push notifications with Firebase Cloud Messaging. The most broad approach is to send a notification to a segment of your users. This could be as broad as all of the users for your Android app, but typically you're going to drill down to a smaller audience. For example, you might want to target all of your Korean Android users whose last app engagement was more than 10 days ago. And that will tell you exactly how many users will receive this notification, as well as their relative size to the total user base. On top of that, you can use Firebase predictions to dynamically segment your users and send notifications based on the type of engagement you're trying to get. And that means you can just fire the UX person who's in charge of doing this manually and let Google's AI handle it.
What are you gonna fire me?
No! I already fired you! Why are you still here?
Another option is to manually subscribe a user to a notification topic. This is useful if you want a user to opt into a certain topic, or if you want to programmatically assign them to a topic in the background of your app. For example, a user might follow a certain category like puppies, so you want to subscribe them to puppy notifications. Then the third and most personalized way to send notifications is to send them to a single device or user. And you can do that because every device that you have permission to send notifications to will give you a token. A token itself is just a string that identifies the device, and in a few minutes we'll look at how we can save these tokens to Firestore and associate them with a user. And that makes it possible to send notifications based on individual user activities. Now, as we'll see in this video, the actual sending of notifications can either be done on the Firebase console, or you can do it programmatically with a cloud function. In most real-world applications, you'll be doing most of the notification sending with a cloud function, especially if you're sending to individual device tokens. Now that you know a little bit about Firebase Cloud Messaging, let's go ahead and jump into a Flutter app that has already been configured with Firebase for both iOS and Android. On Android, there's only one additional optional step to set up push notifications. You just need to add this intent filter to your Android manifest file. On iOS, there are a few more steps involved because you need to register a certificate with the Apple Push Notifications service. There's already a detailed official guide for this, so I'll go ahead and link to that in the video description. The next thing we'll take a look at is the pubspec YAML file, and you can see here we have Firebase Core, Auth, Cloud Firestore, and Messaging. Now if we go into the main Dart file, you'll see here that I'm importing Dart.io so we can do platform checking, and we'll also import our Firebase services. Now typically I try to keep the business logic separated from the UI logic, but this is a situation where our logic is pretty tightly coupled together, and I think it makes the most sense to handle everything in a single stateful widget. So this message handler widget will take care of getting permission from the user, saving the device token to the database if necessary, and displaying the actual UI elements when a notification is received. Now, the first thing that we want to focus on is the UI, and there are three different callbacks that you need to know about. The onMessage callback will typically be called when the app is running in the foreground. That means the user is actively using the app when the message is received. Then you have the onResume callback, which will be called when the app is running in the background, and the user clicks on the notification from the actual device. And the third callback, onLaunch, will run if the user clicks on the notification, but the app is completely terminated and needs to reboot. Now, when it comes to Android, you need to set the click action to Flutter notification click to use the background or terminated callbacks. And we'll look at exactly how to do that when we get to the cloud functions. Now, the only callback that we care to implement for this demo is onMessage when the app is in the foreground. And we can use one of Flutter's built-in widgets like a snack bar or an alert dialog. The snack bar approach is a lot more subtle because it just shows a bar down at the bottom and will be automatically dismissed if the user doesn't engage with it. But if you have a really important message that should interrupt the current experience, then you can use an alert dialog. And that will force the user to manually dismiss the message. Inside of a init state, we'll call FCM configure to set up the callbacks that will handle the message when it's received by the device. And each one of these callbacks will give us access to the actual notification data payload. To display a snack bar, we can first define the snack bar widget, and then we'll set the text to the notification title. And you can optionally add an action here to go to a different screen when the user presses on the notification. Then to actually show it, we call scaffold of context show snack bar, which will look up the widget tree for the nearest scaffold and display it. So that's all we need for a snack bar. If we want to show an alert dialog, we can use the built-in show dialog method, and then define a builder that defines an alert dialog, and we can pass that the notification title and the body. And then we can dismiss the alert by simply calling navigator pop. Now we could also define the on launch and on resume callbacks, or we can leave them blank, which will just cause the app to be opened if a notification is clicked on. In most cases, you'll probably want to navigate to a specific screen when the user clicks on a notification in the background. At this point, we actually have everything in place we need to start receiving notifications on the device, as long as that device is Android. On iOS, you need to explicitly request permission from the user. And that's actually really easy to do. We simply call FCM request notification permission and then pass in the iOS notification settings. Now, if we go to the Firebase console and send a notification to a segment, it should be received by this device. Now, the next thing we might want to do is subscribe the user to a specific topic. You can subscribe or unsubscribe from a topic with a single line of code. You might do this entirely in the background, or you might have a button that says subscribe to puppy notifications that the user clicks, and now they're subscribed to that topic of notifications. And now if we want to send a notification to all devices subscribed to that topic, we can do so in the Firebase console or with a cloud function. But what if we want to send notifications to an individual user or device? To make that happen, we'll need to retrieve the FCM token from this device and then save it in a backend database somewhere like Firestore. Before we implement the code, let's start by looking at the actual database model. We have a users collection that contains some information about a user profile, and then under that, we have a sub-collection called tokens, and each document in this collection represents a device token that the user has given us permission to send notifications to. And a token is nothing more than a unique string, so we can use the actual device token as the document ID in this sub-collection. And that just makes it easy to enforce uniqueness for each document in this collection. Now, getting back to our Flutter code, the next thing we'll do is implement a method called saveDeviceToken. And I'm just referencing a mock user ID, but in a real app, you would most likely await the auth current user after you've already logged a user into your app. From there, we can retrieve the FCM token from the device by calling getToken. And then we'll make a reference to that token subcollection under the user that uses the FCM token itself as the document ID. And then we can also save some optional information here if we want, like a created at timestamp or the platform operating system. From there, we'll go back to our initState lifecycle hook on this widget. And on Android, we can simply run this code when the widget is initialized because the token should already be available. But on iOS, we need to make sure that the user has actually finished giving us permission. So we'll go ahead and listen to the stream, and then once we have data, then we'll go ahead and save the device token. Now go ahead and restart your Flutter app, and you should see the device token being saved to Firestore when you fire it up. Then you can go ahead and copy that token and bring it over to the FCM screen, and you can send a notification directly to this device. So that takes care of all of our front-end code, but now the question becomes, how do we dynamically send notifications to a user based on their actual activity in this app? And the best answer to that question is Firebase Cloud Functions, although you can use any of the Firebase admin SDKs to send messages. Go ahead and run Firebase init functions from the root of your project, and I would highly recommend using TypeScript as the language here. And if you're not an expert with TypeScript or JavaScript, don't worry, because the implementation details for this code are really simple. First, we'll go into the index.ts file and import Firebase admin, initialize it, and then set up variables for Firestore and FCM. When it comes to sending notifications to a specific topic, you'll most likely do that when something changes in the database. For example, you might have a puppies collection and you want to notify everybody subscribed to the puppies topic when a new document is added to the database. We can do that by setting up a cloud function that listens to the Firestore onCreate event in the puppies collection. When a new document is created, that's going to give us access to the puppy data on that document, and then we can create a notification payload with that data. The cool thing about this is that we can use the data in the Firestore document to customize the notification itself. For example, we'll say puppy name is ready for adoption. Now, there's a lot of different ways you can customize the notification itself, but the most important properties are the title, body, and icon, because they dictate how it appears on the actual notification tray on the device. And you'll also want to set the click action to Flutter notification click if you want to use those background callbacks that we looked at earlier. And the final step is to simply send the notification, which we can do by calling FCM send a topic, along with the topic name and the notification payload. And that's all the code it takes to broadcast a notification out to potentially millions of devices that are subscribed to this puppies topic. Now let's go ahead and write a second cloud function that will listen to the orders collection, and then it will send out a notification to an individual user whenever they've received a new order. When an order document is created, we'll assume that there is a price, a product, and then a user ID for whatever user sold that product. In the cloud function, we'll go ahead and take that user ID to make a query to that tokens collection under the user ID. That will give us a query that returns all of the device tokens for a specific user. Now, because each one of those documents uses the actual FCM token as its ID, we can simply map the snapshots down to an array of the document IDs. Then we'll go ahead and format the message payload just like we did in the previous example, and then we'll say FCM send to device with this array of tokens. And that will send out a push notification to every device owned by this user. Now, the final step is to deploy the functions. Then if we go into Firestore and create a document, it should broadcast the notification to our emulator or local device. And we now have a full stack solution for cloud messaging that can handle multiple paradigms of app notifications. I'm going to go ahead and wrap things up there. If this video helped you, please like and subscribe, and consider becoming a pro member at Fireship.io to get access to the full Flutter Firebase course. Thanks for watching, and I will talk to you soon.